All right, let's take a look at how to list all possible rational zeros of a polynomial. Now, when we say all possible ones, basically this theorem is called rational root or rational zeros theorem. It just says, okay, where should I look for roots? And it turns out that all you have to do is, first of all, look at the constant term. In other words, the last number, okay? So you're looking at this number. You want to list all possible factors of that number, okay? How do we do that? Okay, so let me show you. We're going to open up a calculator. Let me just clear everything I have here. Start with the number and divide it by 1, because 1 is always a factor. So put 1 here. 10 over 1 is obviously 10. So 1 is a factor and the number itself is a factor. Are there any other factors? Well, let's try 2. Is 2 a factor? Yes, because the answer is 5. Okay, so 2 and 5, they always come in pairs. Those are factors. Now, notice how here it says plus minus. So also all the negative ones are also factors. Negative 1, negative 2, negative 5, negative 10. It's just easier to write it using plus minus. Are there any other factors? No, they're not. Because if you divide by 3 or by 4, 5 we already know it is, 6, no, 7, no, 8, no, 9, no. So none of them are factors. Okay. How about 5? What are factors of 5? And why 5? Okay, so again, you start with factors of the last number. You don't really care about the sign because it's plus minus anyway. Then you go to the factors of the first number. Okay, so first factors of the last number, then factors of the first number. What are factors of 5? Now, the good news that 5 is a prime number, which means that the only factors are 1 and 5. You know that dividing by 2 or by 3, by 4 is not going to do anything. And it's plus minus, again, because it could be positive or negative. You just don't have to list them all. And the rational root theorem says this. Now, to find all possible rational zeros, what is rational? They're fractions or integers. You need to take these guys and divide it by these. Okay, so take the factors of the number and divide it by the factors of the first, what's called the leading coefficient. Okay, so what are we going to get? So let me show you how to do that. First, list the factors of 10. What are they? 1, 2, 5, 10. Don't worry about the plus minus because the plus minus already included. Then list all factors of this guy, 5, which is 1 and 5. Now let's start dividing one by the others. Okay, so start with this guy, divided by 1, then divided by 5. So what are you going to get? 1 over 1 is 1, then 1 over 5. Okay? Then move on to the next number, to 2, and divided by 1, divided by 5. So what do you get? You get 2 over 1, which is 2, and then 2 over 5. So that's 2/5. Next, move on to, I'm kind of running out of colors. The next number is a 5, so divided by 1, divided by 5. What are you going to get? Well, 5 over 1 is 5. 5 over 5 is 1, but that one's already included, okay? And then finally, take 10 divided by 1 and then divided by 5. So 10 divided by 1 is 10. And 10 divided by 5 is 2, but that's already listed. Okay, so those are your answers. So this is going to be 1, 1/5. If you want to, you can order them, but you don't have to. 2/5, 5, and 10. And remember, this is plus minus. So what this theorem is saying is that if you're looking for any rational roots of your function, you do not have to look at anything else. Can this function have other rational roots? No. Only these are the ones that will be there.